We are on day 2 of our Unit 11. In this unit we are solving trig equations, and yesterday we solved trig equations graphically. Today we're going to be solving trig equations algebraically. This is day 1, a little intro to it, little basics, and then tomorrow we'll be going further with it. First of all, for AP Calculus, it is very important that you know how to solve all sorts of equations. In calculus, you will be responsible for knowing how to solve all of the equations all the time, randomly. In one problem, you might be solving a log equation. In another, you might be solving an exponential equation, maybe a radical equation, maybe a rational equation, maybe a trig equation. So you need to know how to handle these when they come up. Okay? All right. Techniques and tips. Number 1, when you have a trig equation, we are going to be isolating that trig function. Isolate the trig function. Okay? When possible, you do isolate the trig function by manipulating the equation so that the trig function is alone on one side of the equation. Okay? So move everything except the trig function to the other side. Okay? Namely, the number. Move the number to the other side, keep the trig function on the one side. Remember to keep the argument with the trig function. The trig function has to stick like glue to its argument. It cannot lose the argument. Okay? Then you ask yourself, what must be the reference angle for that trig function and that trig value? Okay? We are going to need to use the saying, all students take calculus. All students take calculus to figure out where we should put that reference angle, okay, to determine which quadrant the reference angle, not function, the reference angle must be in. Note that we are solving an equation. Okay, remember that there are an infinite number of solutions. Okay, this is different from our work with inverse trig functions. Okay, this is different. So you do not restrict the domain, which means you're not going to have like that black hole, the quadrant 3 black hole. You're not going to have that. This is not inverse trig functions because we are solving an equation. Okay, we need to use both quadrants that make the trig function, thus whatever sign the value that we're dealing with is. Okay, for instance, if we have sine of x is equal to 1/2. If we have sine of x is equal to 1/2, sine is a positive in quadrant 1 and in quadrant 2. The reference angle that makes sine 1/2 would be a pi over 6. So x here would be pi over 6 and 5 pi over 6. Those are the two angles that make sine 1/2 from 0 to 2 pi. We're going to be going from 0 to 2 pi again, just like yesterday. Okay? So keep that in mind. This is not inverse trig functions. There is a difference between, there's a very big difference between this, there's a big difference between this and that. Okay? This over here is one value. One value. Inverse sine of 1/2 is just pi over 6. One value. This is asking what are all of the angles that make sine 1/2. Pi over 6 is one of them, but so is 5 pi over 6, right? And we could keep going. Okay, we could add 2 pi to this and get another angle. We could add 2 pi to this and get another angle. We could keep adding 2 pi. We could subtract 2 pi. So we get an infinite number of solutions to this. This, only one answer. That's all you get. From an inverse trig function, you only get one. From an equation, you get an infinite number. All right? So keep that in mind. This is not inverse trig functions. Don't restrict the domains. All right. B here, trig arguments with coefficients. So consider this equation now. Consider sine of 2x is 1/2. When you have when you have an equation where your argument has a coefficient. This is the argument, and it has a coefficient. When you have a coefficient, you're going to treat that argument like one single angle. Okay? You're going to set the 2x equal to all of the angles that make sine equal 1/2. Okay? Then you're just going to divide by whatever number is in front of the x, in this case a 2. You're going to divide both sides by that 2 to get you the single x values. Okay? But we are going to be dividing both sides by 2. So our denominators, when we divide both sides by 2, our denominators are going to be, in this case, 12s. Okay? So this will only give us the x values between 0 and pi rather than from 0 to 2 pi. So to get the remaining x values between pi and 2 pi, we are going to need to find more angles before we divide by that 2. If the coefficient is 2, you're going to need double the number of angles. If the coefficient would be a 3, then you're going to need triple the number of angles. To get those additional angles, you're going to add 2 pi to each of your original angles. And then you're going to divide both sides by that x coefficient, whatever it is. This will make more sense when we do examples. Okay? Hopefully it will make more sense when we do examples. All right. I do need to mention, if we have a calculator to solve a trig equation, I will tell you this. If we had a calculator to solve a trig equation, I would solve it exactly like I did yesterday. Put one side in for y1, first get 0 on one side, put 0 in for y2, and put the other side in for y1, see where they intersect between 0 and 2 pi. Exactly like we did yesterday. But it is worthwhile to mention that we could use the inverse trig capability on calculators. Okay? You can use this key, you can use the inverse key to find only one of the values of your answer. Okay? Then you must find the other values using All Students Take Calculus and logic. It's the best way for me to say that, to name the other angles. Okay? It gets a little complicated if you're using your calculator, and if you find one angle, let's say that that's angle A. If you find one angle and then you go and find another angle, well, your calculator is going to give you this angle, and you need to ask yourself, how can I name that angle? Let's say that this is, I don't know, 0.371. Then what would that one be? Well, if this is 0.371, then this one would be pi minus 0.371, because we'd be subtracting it there. So you're using some symmetry, you're using logic to find out what you need to do to get that value. So yes, you can use the inverse key, but it does get complicated. Instead, you can use the graphing technique that we learned yesterday and find all the values at once. This technique will work all the time. The inverse technique is a little bit dicier. It's a little trickier. Okay? All right. Okay, with that said, let us do some examples. So example 1, we're going to solve 8 cosine x plus 4 is equal to 0 from 0 to 2 pi. So I take my 8 cosine x plus 4 is equal to 0, and I'm going to isolate the trig function. So I'm going to move the 4 to the right, subtract it over, divide both sides by 8. This gives me cosine x is equal to negative 1/2. Okay? So now I'm asking myself two things. Number one, or it doesn't matter which order you go in, which quadrants is x going to lie in? Between 0 and 2 pi, which quadrants is cosine negative in? Well, all students take calculus. All are positive in quadrant 1. Only sine is positive in quadrant 2, so cosine is negative in quadrant 2. Only tangent is positive in quadrant 3, so cosine is negative in quadrant 3. And only cosine is positive in quadrant 4, so I'm not going to put it over here. So quadrants 2 and 3 make cosine negative. The reference angle is the angle that makes cosine a half. Cosine is a half at all the pi over 3, right? So the reference angle is pi over 3. Therefore, my x value, my final answer here, is going to be the pi over 3 angle in quadrant 2 and the pi over 3 angle in quadrant 3. That will be 2 pi over 3 in quadrant 2 and 4 pi over 3 in quadrant 3. Those are the two x values that satisfy this equation. Number 2. State the value or values of x in between 0 and 2 pi which satisfy this equation. So we have that equation. I'm going to copy it down. Okay, we're going to isolate the trig function. There's a sign on both sides, so we can combine those. They're common terms. I'm going to get it on the left, so I'm going to subtract 14 sine x on both sides. I don't really write this, but I'm going to write it for you for this in this case. Okay, this will give us a negative 6 sine x plus 3 is equal to 6. Subtract 3 to the other side. Divide both sides by this negative 6, and we get sine of x is negative 1/2. Okay, time to think quadrant and reference angle. So which quadrants is sine negative in? Well, sine is negative in quadrant 3 and 4. That's where sine is negative. The reference angle is the angle that makes sine a half. Sine is a half at pi over 6. So my answer here, my x value, will be the pi over 6 angle in quadrant 3, that's 7 pi over 6, and the pi over 6 angle in quadrant 4, that is 11 pi over 6. And those are the two angles between 0 and 2 pi. Those are the two x values between 0 and 2 pi that satisfy this equation. Okay? Number 3, find the value or values of x in 0 to 2 pi. I'm trying to give you different ways that you might see it in 0 to 2 pi, which satisfy this equation. Okay, we're going to isolate the trig function. So I'm going to move the 1 to the left, to the right, and then I'm going to divide both sides by the square root of 3. We can rationalize this, and we get tangent of 2x is equal to square root 3 over 3. Okay, you guys, it is very, very important. Do not divide by this 2x. Do not divide by 2x. This is the argument of the trig function. Okay, it is not. This does not mean tangent times 2x. That is not what that means. This is notation. This is function notation. You do not divide by that 2x. You never divide by the argument of the trig function. It is stuck on there like glue. Never divide by it. Okay? All right. Instead, we have isolated our trig function. Our trig function is by itself. And the trig function is equal to the square root of 3 over 3. So think quadrant. In which quadrants, there are 2 of them, there's always going to be 2 of them, in which 2 quadrants is tangent positive? Well, tangent is positive in quadrant 1, and tangent is positive in quadrant 3. Now what is my reference angle? The reference angle is the angle that just makes tangent square root 3 over 3, and that is pi over 6. 2 3s, pi over 6. Okay? So, our argument is this 2x. Usually we go off to the side and just write x equals. Well, here it's not just x equals, it's 2x equals. So 2x is equal to the pi over 6 angle in quadrant 1, that's just pi over 6. The pi over 6 angle in quadrant 3, that's 7 pi over 6. Okay? Now, I could right now divide both sides by 2 and get x, but that will only give me half of my answers. I know it will only be half because when we divide by 2, we're going to get 12 in the denominators, right? And when we get 12 in these denominators, that means we'll have pi over 12 and 7 pi over 12. 7 pi over 12 is still it's still less than pi. So we have only gone from 0 to pi to get that. We want to go to 2 pi. It's very easy. All you have to do is put 2 more values here. Take this one and add 2 pi in the form of 12 pi over 6. So we're going to have pi over 6 plus 12 pi over 6, and that will give me this next value here, 13 pi over 6. One more. Take your 7 pi over 6 and add 12 pi over 6 to it. So 7 pi over 6 plus 12 pi over 6 will give me 19 pi over 6, and that gives me that other value. If I kept going, then divided by 2, I would be over 2 pi. So I don't want to keep going. I'm just going to stop with this. If there's a 2 here, you're going to have double the number, so you're going to have 4 answers there. Now, I am dividing by 2, which is the same thing as multiplying by 1/2. I am going to multiply by 1/2 because it's easier because I'm having fractions. I have fractions here. So pi over 6 times 1 over 2 is pi over 12. 7 pi over 6 times 1/2, 7 pi over 12. 13 pi over 6 times 1/2, 13 pi over 12. 19 pi over 6 times 1/2, 19 pi over 12. And if you notice, we're still less than 24 over 12 pi. So we are still less than 2 pi. These are all of our x values. Let's do another one like that. Okay, we're looking for all the values of x from 0 to 2 pi that are solutions to this equation. This time we have a 3x. I'm just going to treat it like a plain x until the end. Alright? So I'm going to move the 1 over. And now divide both sides by square root of 2. I'm going to rationalize this because it looks more familiar to me. But we do have cosine of 3x is square root 2 over 2. Cosine is positive in quadrants 1 and 4. My reference angle, the angle that makes cosine square root of 2 over 2, is pi over 4. So, right now I have 3x is equal to, 3x because that's what I have there. 3x is equal to pi over 4 and 7 pi over 4. Okay, I put a comma because I have a 3x. I need 2 more sets of these pi over 4 values. 2 more sets. I'm going to add each time I'm adding 8 pi over 4 because I'm adding 2 pi. Pi over 4 plus 8 pi over 4 is 9 pi over 4. Seven pi over 4 plus 8 pi over 4 is 15 pi over 4. Okay, that got me two more. And now I need 2 more because there's a 3 here. I'm going to triple my number. I started with 2. I'm going to need to end with 6. So now I'm taking this 9 pi over 4 and adding 8 pi over 4. And I get 17 pi over 4. 15 pi over 4 plus 8 pi over 4 is going to be 23 pi over 4. Okay? And now find x by multiplying both sides by 1/3. So x will be pi over 12, 7 pi over 12, 9 pi over 12, 15 pi over 12, 17 pi over 12, and 23 pi over 12. For a multiple choice answer, you would reduce both of these because there's a 3 on top, 3 on the bottom. That would be 3 pi over 4. This would be 5 pi over 4 for a multiple choice answer. Okay? But unless they say to simplify these, it's fine to leave it like this. Okay? The other ones cannot be simplified. Reduced. Alright? One more. Find the solutions of this equation. So this time we have a little 1/2 x as our argument. So we have 7 tangent of 1/2 x plus 7 is equal to 0. I'm going to isolate my trig function, subtract the 7 to the other side, and then divide both sides by 7. Okay? Think about quadrants. We have tangent that's a negative. Well, tangent being negative needs to be in either quadrant 2 or quadrant 4. And the reference angle, okay, the angle that makes tangent 1 is pi over 4. So my 1/2 x will equal the pi over 4 in quadrant 2, that's 3 pi over 4, and the pi over 4 in quadrant 4, which is 7 pi over 4. Okay? If we had a 2x, we wrote double the number of answers. If we had a 3x, well, if we had a plain x, we just wrote the 2 quadrant angles. If we had a plain x, 2 quadrants were done. 2x, take our 2 quadrants and double it. 3x, where's our 3x? 3x, take our 2 initial quadrants and triple those. Okay, not triple them, but write 3 times the number of angles that were there. Here we have a 1/2 x. What do you expect will happen here? I expect that I'm not going to be using this guy at all. I'm expecting to take half of my answers, which I will. But let me show you why. Right now, if I just multiplied both sides by 2 to get rid of this 1/2 over here to solve for x, this would be 6 pi over 4 and 14 pi over 4. That reduces to 3 pi over 2 and 7 pi over 2. 7 pi over 2 is bigger than pi over 2. 7 pi over 2 is bigger than 2 pi, so we don't use that one. We only keep the one that is in the interval that we're supposed to find answers in. All right? And that is day 1 of solving trig equations algebraically.